For our next technical session, we have Mr. Ehsan Salehi, Field Application Manager at LDRA, USA. He will be sharing his thoughts on face standard verification and validation for safety environments.
Hello, my name is Ehsan Salehi, one of the field application engineers for LDRA, working in Atlanta, Georgia, in the United States. Today's presentation is about face standard verification and validation for safety environments. In today's presentation, we will talk about face standard terms and definition. Basically, we will talk about what is face, what is included in face, and then we talk about the face conformance process. And at the end, if there is any questions, we would answer those questions. Face standard terms and definitions. FACE Consortium has established a FACE conformance program and defined an associated conformance policy for the FACE technical standard. It was about 2012 when United States Army and Navy decided to come up with the solutions for all the avionic software to have a methods in order to upgrade them in a better and more efficient way. The FACE as an open architecture standard was a solution that was provided back in the time. The FACE conformance program provides the associated conformance criteria and process necessary to assure the units of conformance, what we call it the UOC. This term would be used broadly during this presentation. And these UOCs are developed according to the FACE technical standards. The FACE conformance program consists of the verification, certification, and then the registration. So there are 3 steps involved with the FACE conformance process: verification, certification, and registration. FACE consists of 5 individual segments, which they are all independent of each other. Operating system segments, which is called OSS. Input and output service segments, which is called IOSS. Platform-specific service segments, which is called PSSS. Transport service segment, which is called TSS, and portable component segment, which is called PCS. This picture shows the layout of the FACE in terms of all the different segments and their interoperability to each other. As you can see, the portable component segments is laying on the top. They are usually responsible for common functionalities. Transport segment is used as a means of data and the communication of the data between all the portable components and also all the platform-specific components, besides some of the exclusive exceptions, which we will talk about them later. The I/O segments is responsible to communicate between the operating systems and all the platform-specific segments. The platform-specific segment is comprised of a sub-segment, including the platform-specific device services, platform-specific common services, and platform-specific graphic services. Basically, if you are a developer and you are trying to create some special algorithm to come up with a solution for your graphic cards or any display programs in your avionics systems, any of your secret sauce would be in place in the platform-specific segment. Platform-specific device services are where the management of the data and the translation between the platform unique interface control documents, which is called ICDs, and FACE UOP supply models or USM occurs. The platform-specific common services are comprised of the higher level services, including logging services, device protocol mediation, streaming media, health monitoring, and fault management. Basically, any of those specific concrete modules would be developed inside of the platform-specific common service, which is a part of the PSSS. Platform-specific graphic service, as we explained, are going to be the presentation management and basically abstracts of the interface specific to the graphic processing units, what we call GPU, and the other graphic devices of software components with a face reference architecture. Portable component and basically the transport service. The transport service is comprised of the communication services. The TSS, or transport service segments, abstracts a mechanism and a data access to the software components and facilitate integration into the disparate architecture and a platform using a different transports. TSS unit of conformance, or UOCs, are responsible for data distribution between the PCS and PSSS. So basically, when there is going to be a communication between a PCS segment and a PSSS unit of conformance segment, that would be the transfer service segment only, not iOS. That's very important. The portable components are basically the software components providing the capability and the business logic. The PCS components are intended to remain agnostic from the hardware and sensors. Additionally, these components are tied into any data transport or operating system implementation to meet objectives of the portability and interoperability. To be speaking in a more common language right now, PCSs are the modules that you are not going to change a lot when you are designing your system. For example, if you are changing the kilometer to a mile, if you are using a polar GPS systems versus a non-polar one, all of those convergence can be facilitated inside of the PCS. The operating system and I/O segment. The OSS, or operating service segments interface, provides a standardized means for software to use services within the operating systems and other capabilities related to the OSS. The OSS interface is provided by 14 open group standard, basically 2020 OSS UOC 2 UOCs in other segments. These interfaces includes the ARINC653, POSIX, HMFM APIs. The OSS interface optionally includes one or more of the following networking capabilities, which is called programming language runtimes, component frameworks, lifecycle management, and configuration service interfaces. In input and output service interfaces, as we explained before, are responsible to communicate between the operating system and platform-specific service segments. Face technical standard. So all of these standard terms and definition was all integrated into the face technical standards. So the face technical standard is developed and maintained by the Open Group FACER Consortium. The face technical standard released in different editions, and there's going to be several editions. So right now it would be 3.1 edition, which was released about 2 months ago in the February of 2021. The conformance program allows the conformance for any valid published editions, and the approved correction process provides a path to conformance to editions with known problems. Basically, if a supplier finds a problem with the face technical standards, they submit a problem report, and any updates to the problem report that is consequences as it changes to the face technical standard would be called approved correction. When we are talking about a face, it's a lighter process to verify conformance to the technical standards. So basically, we wanted to make sure if there is a process involved with the conformance, the process minimized to the interfaces and not the functionality of the actual software. Conformance is primary to the face-defined APIs. So basically, the face conformance testing does not require execution of the software. In a better terms, if your software is working or not working as you are specifying in your high-level requirements, it is not concern of the face to test those high-level requirements. All the face standard concern is basically your software is meeting the actual requirement in the face technical standards. The UOC supplier tests the UOC functional requirements. So for technical standard requirements that can't be verified by the conformance test suite, the supplier will provide evidence for the UOC that meets the requirement, which we'll talk about this in more details later. Conformance is not a verification of a UOC functionality, so we are very specific on that term. It's all about to make sure the interfaces that are used for your UOCs are all meeting the phase technical standards criteria. Phase conformance is more similar to a UL sticker, basically won't burn your house down than a flight qualification. So functions as specified. Basically, when you are having the interfaces are checked, that means the interfaces are all to the phase technical standards. But you can use other process such as DO178 process in order to verify the actual functionality of your software that meet and adhere to this to the other standards. So the phase conformance policy does not impose any additional burden to check this work. Each edition of the phase technical standard specifies all the requirements needed for the conformance and is the governing documents for those requirements. The phase conformance verification matrix is not intended to add or modify the requirements from its corresponding edition of the phase technical standards. In case where the conformance verification matrix differs from the phase technical standards, the reference phase technical standard takes the precedence. Basically, if there is any differences for mistakes or unintentional by the CVM or conformance verification matrix, it is the phase technical standards that the verification authority will care the most. So the phase conformance verification provides a guidance and clarification and illustration of how the requirements are met. In a simpler form, in order to know what exactly you need to do for a supplier need to do for every single requirement, the phase conformance verification matrix is designed. The units of conformance is all defined within the phase conformance verification matrix and phase technical standard, which are the same. So if a UOC is going to be a conformant, we don't call it a conformed UOC. We would call it a candidate to the conformance of the UOC for phase technical standards. Now we are going to talk about phase conformance process. The phase conformance process will be conformed by two following authorities: verification authorities and certification authorities. Verification authority is responsible to ensure the software supplier artifacts are provided at what is required to be satisfied by all the requirements in phase technical standard, which is categorized in the conformance verification matrix. We will talk about the conformance verification matrix in more details. The certification authority is responsible to create a library for each conform UOC and make sure all of the process taken by the supplier and VA are adequate and verified. Phase conformance assurance and automated phase of testing can be provided in order to ease out the process. For example, a tool such as LDRA can be used to fulfill some of the very important phase needs for software supplier trying to build a UOC for automation and assurance level. Basically, the phase or basically any of the LDRA tool suites component can be adhered to any specific phase UOC modules or phase UOC segments. The screenshots above shows how a CVM is laying out different columns to help user in conforming the proposed UOC. A verification tool such as LDRA imports the selected segments requirements into the TV manager, mimicking that of the CVM spreadsheet. Moreover, additional columns have been added to benefit the user from the years of the phase experience, such as FAE experts that are working with the LDRA, they are going to be experts to the face. One particular in additional guidance columns, basically, for example, is we are adding in the LDRA TV manager the additional guidance in order to explain what is exactly required for this specific requirements that user or supplier is trying to conform. As you can see, there is a conformance verification methods. There is a supplier artifacts area, along with the specific segments that is categorized in the phase conformance verification matrix and is important to the TV manager. This is just to illustrate the value what LDRA tools like LDRA can provide towards the guidance. Basically, you can use TV manager in order to see the status of your phase unit of conformance and making sure you are meeting all the requirements and you are supporting any evidence that is needed for any specific requirements, and whether if you are having a partial fulfillment or you are fully fulfills all the artifacts for this specific requirement. Here is the snapshots. For example, the CVM 2174, which is the TS and iOS service interface, utilizes POSIX APIs. This one is marked as a partial because you in the CVM, the user needs to provide basically a fully tested requirement, which needs a software test procedure, software test result, and also the software requirement specification for the specific requirement. Also, if a specific requirement is marked as a conditional, the conformance statement also needs to be provided for that particular requirement in the last column of it, in the last table of it, and basically explaining what exactly user have done in order to satisfy or justify this requirement, whether if they wanted to use it or not. These documents serve as a templates artifacts guiding the user as to contents as expected to be found in them. So this is one of the huge value of all around. So user can provide their artifacts such as interface control document or ICD, software product specification or SPS, interface design descriptions or IDD, software requirement specification, interface requirement specification or IRS, software test plan, software architecture descriptions, and also software test reports. Basically, these are the artifacts that user must provide for one or many of those CVM requirements associated to the segments. Along with that, there are some of the requirements that are marked as a fully tested requirements. Most of those fully tested requirements that they need to provide with a software test plan, software test requirement, and software test results can be just as simple as code inspections. For those, a tool such as TV Vision providing phase standard can be used to check the existence or not existence of a specific phase requirements value that was imported to the phase CVM. User can use the TV Vision and categorize their software and basically analyze their software and then see the code review results in order to see if the actual value has been passed or not. Along with that, if the user or company has other standards such as MISRA or certs for security, they can integrate those standards with the phase and create a customized standard and they check their code statically. So in order to create a test and using the code inspections, user can actually simply go ahead and use the LDRA TV Vision static analysis to see the process results. One example is that it checks for the adherence of specific sections of POSIX API, ensuring that the UOC function signatures are syntactically correct enforcing the proper use of certain language constructs. Additionally, some of the phase requirements in the CVM marked as a test, and they need to be used application which is provided by the open group called Phase Conformance Test Suite. This Phase Conformance Test Suite is independent of any other software such as LDRA. User must provide their data model, they must provide their objects or the libraries associated with the unit of conformance to that specific phase segments to the Phase Conformance Test Suite. Once all of these has been published and inserted, the Phase Conformance Test Suite can be run, and the past result of the Phase Conformance Test Suite can be used for all of those requirements associated with the specific phase segments that the UOC is candidate to the conformance to it. So the phase CTS tool is used to verify the conformance to the phase technical standards. There are matching versions between the phase technical standards and the accompanying CTS. The version 2.1.1 is one of the most used one, and then the first phase conformance test 3.0 is the one had been basically used in the last 2 years. There is actually a candidate for a new version of the conformance test suite called phase CTS 3.1, which is coming up, and that would be used for the latest edition of the CVM, which would be the CVM 3.1 or phase conformance or phase standard or technical standard 3.1. Within the TP Manager, which is a tool by LDRA, a user can configure and invoke the phase CTS tool for the purpose of testing their UOCs, and further by ensuring a pass score before the submitting to the VA. Once every basically evidence has been provided, the phase CTL basically is being used and you are testing your software. A tool such as LDRA again can be used to add all the additional details to the software supplier artifact cross-reference column, which needs to be fulfilled and submitted to the verification authority. Again, a tool such as TP Manager can be used to automatically pass in all of these data and ensure the conformance has been provided. So therefore, when you are submitting your test cases and your test results to the verification authority, the verification authority can simply verify every single one of those requirements and ensure the values that you have been provided for that requirements is being adequate and correct, and that eases down the process of the phase conformance process, as well as make your conformance product to be easier and less troublesome. As you can see, there would be some conditional requirements, such as security profile, safety profile, general purpose profile, and some other basically conditional requirements. If a requirement is subjected to a conditional requirement, or basically the conditional requirement is not empty, then a user can import the value to the conformance basically justification part of the TP Manager, and that value would be integrated to finalize a statement of verification or conformance statement documents, which basically needs to be supplied with every UOC to the verification authority. So a verification authority can simply see the auto-generated value of the statements of conformance statement and basically ensure all of the conditional requirements have been fulfilled by either verifying them and how you are verifying them, or justifying them why the user is not using that specific requirement. Aside from that, phase conformance statement means user has to be conformed to 100% of all the requirement associated with the phase segments. The only exception is the phase or conditional requirements. Again, thanks for listening to the presentation. Hopefully it will provide values to you, and you can use this presentation as a guidance for the phase conformance product. Thank you.